Good afternoon. I wanted to give you guys a little update for the Chapter 5 on lipids. I will do this in two parts, so you'll have a part 1 and a part 2. So I want to talk to you about the different types of lipids and fats. We kind of use that term fats as all-encompassing, but really lipids are a component of fat, which are solid at room temperature, and oils, which are liquid at room temperature. And all lipids, regardless if they come from fat or oils, have 9 calories per gram. So the simplest form of lipids are called fatty acids. As we learned in Chapter 4, the simplest forms were monosaccharides. Those are the building blocks of the starches. And fatty acids are the building blocks of the type of lipid called triglyceride, which is the form in which we find lipids in our food, and it's also the way lipids are stored in our body. Another form of lipids are called phospholipids, and what this just means is the phospho is phosphorus attached to the lipid, and what it does is it makes this a water-soluble version. I'll show you a picture of it later. And then lastly, we have the sterols, which are an example of that would be cholesterol. So not that you need to memorize the chemical structure of all the fatty acids, but what I want you to see is that the fatty acid structure is a long chain of carbons with hydrogens attached to it. The amount of saturation determines the type of fatty acid. So this is an example of a saturated fat, where all of the carbons have hydrogens attached to them. And this is an example of a monounsaturated. So there's one place in which that carbon bond turns into a double bond and the hydrogens are not attached. And once we get into the polyunsaturates, we see an example of 2 places or more that those double bonds form. So here's some examples of a saturated fat. This is stearic acid, beef fat, and it shows you that all the hydrogens are connected to the carbons, so this is saturated. Then we move to the monounsaturated, where you have 1 double bond, and then the last 2 are an example of an omega-3 fat, which is a polyunsaturated fat, and an omega-6 fat, which is a polyunsaturated fat. And the reason that they're named omega, it has to do with the carbon number from the methyl end, okay, this is the beginning, okay, where the first double bond occurs. So on an omega-3, we see 1, 2, 3. On the 3rd carbon is where the first double bond occurs. That's called an omega-3 fatty acid. So let's talk a little bit more about where we find these. So we find the fatty acids and triglycerides in our body, and we find them in foods. Saturated fatty acids, we tend to be solid at room temperature, and we tend to find those in animal fats. Unsaturated fatty acids tend to be in plant foods. So here's an example of some of the fatty acids. Saturated fatty acids include things like coconut, butter, palm oil, lard, or beef fat. Monounsaturates tend to be more like olive oil, canola oil, peanut oil. And the polyunsaturates are more like safflower, sunflower, corn, and soybean. So you see that each fat is actually, each oil is a combination of different fatty acids, but what we say is they're primarily made up of saturated fats. So let's talk a little bit about the 2 essential fatty acids. The 2 essential fatty acids are alpha-linolenic acid, which is an omega-3 fat, and linoleic acid. Now these fatty acids must be consumed in the diet. When I say essential, what that means is the body does not consume those. So the omega-3 fats that we need are found primarily in nuts, seeds, fish oils, flaxseed oil, also canola oil, nuts, mussels, crab, shrimp, soybean oil. And this is again a picture of an omega-3 fat because we've got that double bond on the 3rd carbon. And omega-6s are found primarily in vegetable oils. And it's called an omega-6 because the first double bond occurs on the 6th carbon. So let me differentiate these 2 fatty acids. Both of these fatty acids are polyunsaturated fatty acids, or PUFAs. One of them comes from the omega-3 family, the alpha-linolenic acid, and one of them comes from the omega-6 family, linoleic acid. You hear a lot about the healthful components of omega-3s, DHA and EPA. These are 2 components that are very important in the body to help reduce inflammation, help prevent blood from clotting within the vessels, and to help in the nervous tissue and the function of the myelin sheaths. The arachidonic acid, although we do need omega-6s, the problem is we consume a lot of these, and arachidonic acid is more likely to cause inflammation response as well as blood clotting. So those are the simplest form fatty acids. When we move to talk about triglycerides, what we're talking about in triglycerides is a glycerol backbone with 3 fatty acids. So I'll show you a picture in just a second. A phospholipid is like a fatty acid in that it has a glycerol backbone, but it also has phosphorus. And our bodies can make these phospholipids, and this is what our cell membranes are made up. Now, sterols our body can make as well, but the example of the sterol that we have in our body is cholesterol. And remember, cholesterol is a way that our body packages fats that we eat. And so you'll often hear of good cholesterol and bad cholesterols, which I'll talk about in a minute. But of those cholesterols, the one that we want to watch out for is the LDL, or low density lipoprotein. All right, let's talk a little bit about the foods that we find fat in. Okay, so when we look at the MyPlate, the majority of fats that we get are primarily from protein in the dairy group. The only reason that we even find fats in these is the way that we prepare them. Now, this says avocados, but avocados is in the fat group, which is one of the reasons I don't like Choose MyPlate, is that avocado isn't an example of a fruit. I mean, maybe botanically it is, but it's made up primarily of fat. Phospholipids can be found in foods. Our body also makes phospholipids. And phospholipids acted as an emulsifier, so again, making oil and water be able to be emulsed or brought together. Cholesterol is a very important component for making hormones in our body. And again, cholesterol is only found in animal products, and it's because you need a liver to actually make cholesterol. So let's look at some of the cholesterol in foods. If you notice, all of these foods are animal foods. And the reason that brain and liver is so high is this is where cholesterol is stored in our body. Okay? So those are some examples. The recommendation for how much cholesterol we should eat is typically less than 300 milligrams a day. However, most dietitians and physicians agree that if you don't have an elevated blood cholesterol, you should be more worried about the saturated and trans fats that you eat in your diet than the amount of cholesterol. So this gives you an idea of how much fat is in certain foods. And if you notice, we get into the proteins and the oils, okay, and the dairy, and that's where we get most of the fat in our diet. It's also important to look at nutrition labels to see how much fat is in something. Total fat is listed always, and then we only list saturated and trans fats. We don't have, on the food labels, don't have to list the mono and the poly. Why do we eat fat? Fat is important because it gives us a lot of satiety. It helps us feel full. It helps our brain signal that we've been eating enough. Fat provides a lot of flavor in food, and it gives food a really nice texture. Let's talk for a minute about trans fats. So trans fats are a type of fatty acid that have been made because of human intervention. So humans took a healthy fat, like a polyunsaturated, and they added hydrogen to that. Okay? The reason that they did that is it actually increases the shelf life of food because it's less likely to go rancid. So if you have a nice vegetable oil, you literally add hydrogen molecules under pressure, and you actually, what you do is make this a semi-solid or partially hydrogenated fat. The problem with hydrogenated fats are that trans fatty intake increases your risk for cardiovascular disease even more so than saturated fat. So how do I limit the trans fat in my diet? I need to make sure that I look at the food label and look for that word hydrogenated. Because if that's on there, then they took a healthy fat and hydrogenated to make it an unhealthy fat. Deep fried foods are typically made with trans fats. Baked goods, especially purchased baked goods, are made with trans fats, and non-dairy creamers. Another significant source that I find in students that I work with are cup of noodles is typically trans fats, as well as microwave popcorn. So this talks a little bit about the types of fatty acids and if they're liquid or not at room temperature. And again, saturated fats typically come from animals, and those are going to be solid at room temperature. Monounsaturated and polyunsaturated tend to be liquid at room temperature. Trans fats, depends on how much hydrogenation they have, tend to be solid. So what are the trans fat recommendations? How much should we eat? The amount of trans fats that we eat is so the trans fat recommendations have been made by several agencies, but the one that I really go to is this National Academy of Sciences, and what they have found is that the trans fats in our diet are more deleterious with respect to cardiac heart disease than saturated fats. So trans fats are worse than saturated fats. And so what we find, and what the statement level that the National Academy of Sciences is using, is that there is no safe level of trans fat consumptions. So I'd really love to see people get trans fats out of their diet. All right, so I'm going to go pretty quickly over how our body uses fats. We also cover this a little bit in Chapter 3. But what I want you to be familiar with is this enzyme lipase. And we've talked about anything that ends with an ACE is called an enzyme. And lipase is the enzyme that breaks fat down. Okay? So what that lipase does is that it acts on the triglycerides that we're eating by breaking them into short and medium chain fatty acids. And so those short and medium chain fatty acids can be put into the blood, but the long chain fatty acids have to actually stay in the lymphatic system. Okay, so this is a review of where the digestion occurs, but what I want to get to is this part right here. Okay, and what's interesting from this part is that when you eat fat, okay, we've talked about the digestion of fat, and then remember in Chapter 3, everything comes from the small intestine through the portal vein to the liver, and then the liver transports this through the blood, which is cardiovascular system. However, remember, some of the fats are too big and have to travel through the lymphatic system. Okay? And so when we look at this digestion process, keep in mind that fat is very big, and so we often use bile as an emulsifier. Okay? But then lipase breaks that down so that we can absorb the monoglycerides through the portal vein, and then the long chain fatty acids through the lymphatic system. Okay, and one key component in here is this concept where to get these through the lymphatic system, I still have to make it water soluble. And the way that I'm doing that is I'm adding a protein and a phospholipid to it. So I'm packaging these triglycerides as a phospholipid, or what we'll also call a transport fat. And so commonly that's called a chylomicron. Sometimes it's called a very low density lipoprotein or a low density lipoprotein. And those are those terms LDL and HDL. So remember, LDL and HDL don't have to do with the fat that's found in food. It's how our body processes them. All right. All right, so finishing up with the digestion, keep in mind that the phospholipids that we eat in our diet, again, break down. And again, cholesterol can be absorbed directly when it's broken down with the enzymes from the pancreas. 95% of dietary fat is absorbed. Short and medium chain fatty acids are water soluble and enter through the portal system, but long chain reform into triglycerides and enter through the lymphatic system. So how do we carry these fats in the bloodstream? Most dietary fats are carried as chylomicrons, okay? And basically what that means is that it's a fat and water soluble form. And a chylomicron also is an example, of a lipoprotein. And again, it's a vehicle used for lipid transport. And here's a picture of it. So you can see the fats in the middle, and then the protein and the phospholipid are on the outside. Okay, so the ones that you're most familiar with are probably this LDL and the HDL. So let's look at a further picture. So in this picture of the composition of the lipoprotein, you can see that the chylomicron and